All right. I still have to. I'm still not used to the new software, right? Well, nevertheless, welcome to another episode of Streaming Clouds. And as always, thank you for tuning in. Kev, you want me to do the introduction of our guest? Yeah.
Yeah, that would be great.
All right. So we got Freek Berson, or Freek, like some people say. So he's a fellow Dutchie. Freek, welcome to the show.
Yeah, thank you for having me. It's definitely glad to be here. So looking forward.
Awesome. So Kev, what are we gonna do today?
Yeah. So, as we've been for the past 6 months, we've been obviously doing a lot on Azure, and we've been doing a lot of topics around the tooling in Azure and deployments. We've done quite a lot on Terraform, right? It's fair to say. So we've got a series coming up on Bicep. So I thought it'd be best to actually get the guy who wrote the book on Bicep, right, onto the show. Right? This guy right here, right? So, demystifying Bicep, right? And his experience. Obviously, he's an MVP. We just had a discussion. How many years have you been an MVP now, Freek?
Yeah, it's over 11 years now. So it's I should probably stop counting now.
You're like a veteran in the game. I know you've got experience in RDS, so remote desktop services. You've also AVD, you're an advocate there, but you've got real life scenarios and experiences, anyway, from what I've read in the book, of using Bicep, right? And from version 0.0.1, etc., of when it was announced. I don't want to steal your thunder because I know you got a presentation, but you've got a lot of experience for such a tool, and that hasn't been out that for only a couple of years, right? And as we know, Bicep is getting better and better. And we know the product team in Microsoft are doing an amazing job on, releasing new features all the time. We've also got, the product manager, Alex Frankwell. He's coming on the show in a few months as well. So it should be a good series. So yeah, let's hand it over to you. I'll stop talking for a bit and we'll get on with it.
Yeah, cool. So I just shared my screen, so hopefully it is visible to everyone.
Get it up. There it is.
There we go. So again, thank you so much for having me on the show today. Happy to be here and to talk some about Bicep. And as a quick introduction, I have a long history, like you said, in the end-user computing space. So doing a lot of projects and customer architecture around remote desktop services, Azure Virtual Desktop, VDI, remote app, etc. I'm working as a product manager at Parallels today, working on Parallels RAS, which is our remote application and desktop delivery solution. Like you said, long-term MVP as well. So mostly on the end-user computing side. So you might be wondering, why is there a talk on Bicep? That's the other thing that I love to do, is anything related to automation, to infrastructure as code, and specifically for the Azure cloud. So hence the session today. So I thought it would be fun to not only talk about all of the technology, but also share some of my experiences and my journey towards Bicep, and how the hell did I end up authoring a book about it. We'll touch on that maybe during the session as well. So if anyone wants to connect now or afterwards, feel free to send me an invite, Twitter, email, LinkedIn. That is all fine. Happy to connect and talk about these and other topics some more. So let's dive in. And I actually want to take you back to the year 2017. And so this is the year that I started diving into ARM templates, because Bicep didn't exist back then. And as it is with, trying to learn any new programming language or new technology or new product, you can read about it, you can read books about it, you can watch videos like this about it. But if you really want to understand the technology, it's all about getting your hands dirty and getting in there and having some experience and actually failing and learning from those experiences as well. That's exactly what I did. So I set myself a goal. I wanted to be able to deploy a remote desktop services, hence the background that I talked about, in Azure IaaS, in any new subscription based on ARM templates, and it should have finished in under an hour. That was the goal that I set for myself and that I worked towards. And I must say, it took me a lot of failed deployments to actually reach that goal at some point. So a lot of debugging, a lot of troubleshooting, a lot of reverse engineering to understand the concept of ARM templates. And we'll touch on that, why that is in just a second as well. But I managed to achieve that goal. And I thought it would be fun, as I'm doing a lot in the community as well, to actually share a session on that and present the stuff that I had figured out and written in ARM templates. So I literally went to a conference in Orlando. This was in 2017 as well. And I brought a big bag of stroopwafels, which apparently is quite a challenge to get through customs in the US. But I managed to do it, and I presented the session, which was called Grab Your Stroopwafel, while we watch ARM do an automated deployment of RDS in Azure IaaS. So I literally went on stage and deployed the environment live on stage. And while that was running, we were enjoying some stroopwafels and watching the deployment go live, and actually me explaining what I did and how I did it and why I did what I did. So that was a lot of fun, of course. And so that was my introduction into ARM templates back in 2017. So if you're not or less familiar, this is, by the way, some stuff that I created back then. So a lot of stuff in Azure, like managed disks and network adapters and virtual machines and SQL servers, etc. But not only that, not only Azure resources, but also a full configuration on top of it. So this is an entire RDS deployment with connection brokering, gateway, web access, if you're familiar with these roles, certificate management, branding, and the whole thing. So within 40 minutes, you would have a full production-ready RDS deployment running in any new Azure subscription in under 40 minutes. So that was the end goal of that session back then. So touching on ARM templates, if you're not or less familiar with that, how do you relate to the Azure Cloud and the Azure Resource Manager more specifically? So this is the diagram of ARM, of Azure Resource Manager. I'm not going to go into all of the details that are on this slide, but I want to focus on the top layer. So where it says ARM, that is basically our front door to all of the resources and resource providers, which allows us to create resources, perform updates, perform deletes, etc. So you, as the administrator, you're able to choose any of the different approaches in order to talk to the ARM engine, whether that's the Azure portal, the UI in the browser, but also CLI, PowerShell, SDK, REST API, and the technology that we're talking about today, the ARM template, which is an infrastructure as code approach, which means that we're not so much firing all kinds of sequential commands to the ARM engine, but rather we are creating a single template that defines the end goal, right? In my case, back in Orlando, that was that RDS deployment, but it could be a virtual machine, a network adapter, a storage account, a Kubernetes cluster, whatever you're doing. So within that template, you define the end goal, you pass it to the ARM engine, and the ARM engine will deploy that in the most fast and efficient way. So taking a look at a template, this is the template format, and this is simplified what it looks like, right? So we have a couple of sections here that allow us to provide parameters in order to customize the deployment or provide values to the deployment upon deploying it. We have the variables section that allow us to specify a couple of static variables, but also functions. But for the most part, you'll be focusing on the resources section. So this is the section that allows you to define, like I said, the resources you want to create. And then you have some outputs in order to output something once the deployment completes. So by the looks of it, this looks pretty simple, right? Just a JSON template and you define some resources and you're ready to go, which is what I thought back then in 2017 as well, until I actually started working with it and it started to become a pretty complex language. Right, with all of the syntax overhead that you have as part of that JSON language, that JavaScript or object notation language, with all of the brackets and semicolons and colons going on. And this is even one of the more simpler ones. But as you can see, these are 600, 700 lines plus of code, which are super hard to digest, to read, to author, and to dive into. It took me, like I said, a lot of field deployments to get to a stage where I had a working ARM template. So for anyone who has experience with ARM templates, you probably recognize that. And hopefully, really, Microsoft actually also realized that. And that is the point where they come up with Project Bicep. So my introduction into Project Bicep was back in 2020, and I started with a tweet by Mark Zunovich, which I'm sure everyone knows. If not, he is the CTO of Azure today, but also the brains behind all of the sysinternals tools. And he literally tweeted that they're working on an open source DSL, a domain-specific language, codenamed Bicep, which would allow us to still have the ARM and the ARM engine, but then get rid of all of the complexity as part of the JSON template. So back then it was called Project Bicep, and he later said, well, it's a code named Project Bicep. So it was the internal name that Microsoft used to reference to that project. And this is actually one of the few projects that actually also made it into the public as the final name of this technology. So I recall that there was a survey going out to a lot of people internally, as well as a lot of MVPs. Once they were working towards the final production version, they were thinking, okay, let's come up with a new final name because it was just codenamed Bicep. And they sent out a survey. And so a lot of people responded to that survey, and they had the option to select one of the new names, but they also had the option to select other and specify their own name. And as it turns out, the vast majority, a lot of people actually sent back, you want other, and we still want it to be called Bicep. And that is why it's still called Bicep today. So the files are actually called .bicep files, the extension, and all the documentation on the docs pages and everywhere is now Bicep. So that was not meant to be, but it's I like the name, and so it's what we know today.
It's a good name, right? Because obviously it's dealing with ARM templates, but it's strong arming the templates into Azure, right? Being Bicep, so it's a good play on.
That's the whole idea. Yeah, so they figured, well, what's the part of the body that empowers the arm? It's the bicep, so we'll call it that. I like it as well. So it's a great name to see it in public as as the official product language name.
It took me a while to figure out that it was related, actually. Right? Sometimes you see a name and you just start using it, and then suddenly you're like, wait a minute. So yeah, I love the name. I love the tool as well. Yeah. So
cool. So the next question that I get a lot, and maybe you have heard about that or wondered about that as well, is I especially got that question a lot over the last year or so. Is people are seeing more of Bicep and they're wondering, how well is this really adopted? How many users are actually using Bicep, and how many resources are actually deployed using Bicep versus what we're using ARM today? Because a lot of people were used to ARM templates, as as horrible as they are to write and to alter and to maintain. But people are actually wondering, how well is that technology adopted? And so what Microsoft did is they of course collect telemetry information about all of the deployments that everyone does in Azure worldwide. Last month they shared some telemetry information about May of last year, and this is the number of resources that are deployed based on Bicep in that month of May last year, which is about 1 million. So 1 million resources were deployed using a Bicep template, or at least Bicep technology. And this is based on the 0.3 version, which was also the first production-ready version at the time. Although it says 0.3, it's a little bit confusing. It's definitely ready for production usage. That's another question that I got a lot. When is it finally going to go into 1.0 so I can use it in production? But it's actually production ready since that version. So that was the usage back then. And then they showed us the usage of last month. This is August 2022, which is, we'd say 23 million resources deployed in 1 month based on back then the latest version 0.9. So if everyone is wondering what the adoption rate is of this technology, this should give you a pretty good picture.
Yeah.
Any thoughts on that?
Go ahead, Kev.
No. I mean, it's an amazing data to see, right? You obviously hear people in the community, trying out different toolings, etc. You definitely see it on Twitter. But yeah, just to confirm, it is fully supported, right? You can raise a support ticket through the Azure portal, or you can raise an issue through GitHub, and there's a product team and a support arm inside of Microsoft, right? So the version numbers are a little off. But I believe version 1 is being reserved for the, the gold standard or whatever it may be, right? Or version 1 is going to be this. They're saving it for a special occasion. So, but they keep on releasing micro changes to this all the time, right, to improve functionality. So
Yeah,
it's a great
yeah,
data
that's
to
actually
see.
a change that they also made fairly recently. Is that they started to release more and more, so that you actually, every month or so have a release cadence in there as well. And like you said, they're saving the 0.1 version mostly because they want to, after that point, have less, possibly breaking changes or anything that they break, as long as they start updating it again. So it's definitely ready since 0.3 for production usage, and I have been using it for production usage since then. And as you can see, the usage has grown a lot since then.
It's something that Terraform had as well, right? It took a long time before it went to version 1.0.0 actually. So
yeah,
it's an interesting approach, and probably we'll kind of see that more and more, right? This triggered something. When I see this, and I'm like, okay, how much resources are being deployed every month, across the whole platform?
Yeah, that's a great question. I don't have the answer, but it makes you wonder, right? So how many resources are deployed in total? I don't know, but it's, this diagram is, of course, I'm sure that Microsoft isn't really fond of, and that's what they said as well, not really fond of, keep on sharing this telemetry information like some kind of marketing machine or whatever. But they just shared it last month because they got a lot of asks from, well, I'm sure you have seen those, one of those questions as well. How well is it really adopted by everyone? And so they made this statement by sharing some of the telemetry there, but I think it will not be a common thing to share this every month or every year or something like that.
Oh, nice. I think this definitely answers the question, right? Is it adopted? In a good way. Yeah. All right. So Ankit asked a question about is Bicep the language that helps to handle JSON? I think we get into that, right?
Yep, we will. Yep.
All right, Ankit, hold tight, man. Your question will be answered.
Transpiling will be explained shortly.
Yeah, absolutely. All right. So, to answer then the next question, what is then Bicep? For those of you who are not familiar, Microsoft calls it a DSL, a domain-specific language. So it's specifically for Azure, which allows you to create resources in a declarative way. We touched on that, right? So no sequential commands firing at the ARM engine, but rather having a single document that contains a declaration of what you want to create. So in that sense, it's exactly the same as ARM templates does. And the next question that I now always get is Bicep going to replace ARM templates? And the answer there is definitely no. So as we'll see later on, what we just mentioned as well, there's a transpiling process. So in the end, the ARM engine will still be processing ARM templates. It's just that we have now an abstraction layer on top of it, which allows us to simplify the authoring experience. So if you take a look at the architecture again, somewhat simplified architecture now, we still have that big blue bar, right? The Azure Resource Manager engine. We still have the ARM templates on top of that. And on top of that, we have the Bicep language. So that is the abstraction layer, abstracting out all of the complex syntax overhead for us and allowing us to have a much better, much more intuitive way to read and to author and to create these templates. So you will be transpiling those templates into an ARM template. And it used to be the case that you have to do that yourself using the command line. So transpiling from one Bicep file to an ARM template and then passing that on to the ARM engine. But today you can also directly pass that Bicep file directly to the ARM engine, and the ARM engine will transpile it for you. So transform it for you into an ARM template and then deploy it. So that means that, there's full feature parity as well. Everything you can do in an ARM template, you can also do in a Bicep template, but then in a much more easy and much more efficient way. What's also a big thing about the Bicep language is the modularity approach. So that means that you can extract pieces of your code, and we'll show this in a demo in just a second as well, and put them into separate Bicep files in order to have much more reusable code as well within your department or within your company or maybe even within the community. And the entire project Bicep is fully open source. So it's all there on GitHub, which means that they are fully transparent about versioning, about features, etc. And you are able also to send in pull requests or feature requests if you think that something is missing or needs to be changed, or if there's a bug. They're definitely actively checking out that channel as well. So how to get started then? That's of course, the title of this, subtitle at least of this session as well. A couple of things that you need, right? So you need the Bicep tool if you at least want to do those transpile actions yourself from Bicep to JSON, or as we'll see later on, from JSON to Bicep as well. You're gonna need a code editor, right? So I can really recommend Visual Studio Code. Super lightweight, but it has all the integrations that you need to get started with Bicep. And as of very recent, also the full Visual Studio is also now supported for Bicep language as well. And lastly, you need some kind of tool to, of course, deploy that template towards the Azure, towards the ARM engine, to the Azure cloud, essentially. So whether that's PowerShell or Azure CLI, or maybe even Azure DevOps or GitHub Actions or whatever you're using, eventually you will bring the Bicep file into the ARM engine to have your resources be deployed. So with that, I suggest we get into a demo, unless we have some questions that we need to answer first.
Yeah, there's one question, Paco. So how reliable nowadays is to convert ARM templates to Bicep code?
How reliable? Well, the fact that it is production ready, I think, should tell you enough. There's full feature parity between ARM templates and Bicep as well today. So literally, it's just that abstraction layer abstracting out all of the complexity in ARM templates. So that's the way you should see it. It's not, like I said, replacing ARM templates. It's just an abstraction layer that helps us make the authoring experience much better. And we'll see that in a demo in just a second as well. We'll do some side-by-side comparison, and hopefully you get a better idea of what that abstraction layer actually does for us.
Awesome. Could it be that it was a little bit buggy in the beginning? So that's maybe...
it was, yeah. So
okay.
I've been using it since the 0.1 version. So definitely since, between 0.1 and 0.3, there have been some breaking changes for sure. But after the 0.3, they have become much more strict in bringing in breaking changes, or at least making sure that there's backwards compatibility. So yeah, if you jumped in at the 0.1 version, a lot has changed. So I challenge you to take a look at the latest version and see what you think.
Awesome.
There is a migration path, because obviously a lot of folks out there would have invested heavily in ARM templates, right? Mm-hmm. If they didn't choose another infrastructure as a code language. So I know the conversion rate or the success rate is a lot higher than it used to be. I think that's what you were talking about there. But for complex ARM templates, maybe there'll be some nuances where you'd have to go in and remediate that. But I believe a lot of the pain is taken away, right, if you follow the migration path. And there's tools around that to help you as well.
Yep. Yeah, I've actually shown some of those migration tools as well. So how to get from an existing JSON file to Bicep, but also how do I just pick one random resource from Azure and show the Bicep code behind it. That's all now possible today. And that's why I really encourage everyone to take a look at the VS Code extension, which I'll also demo in just a second, because that really empowers all of the integration with Azure and doing decompiling and compiling as well. So it's definitely, for me, the best tool to get started with Bicep.
Awesome. Sounds good. I can't wait for the demo. We only have one question left. So do you want to take this one, Freek, or you want to take this one later?
let's save it for now. Let's do a couple of demos first, and maybe we'll answer the question along the way. And if not, we'll come back to it.
Awesome.
Cool. So this is that Visual Studio Code that I mentioned. I'm sure many of you are recognizing it. But the first thing you would do is actually install that Bicep extension. So if I search for Bicep, the extension should come up at least. There we go. So this is the latest version of that extension with a lot of documentation in there as well. You install it, and from that moment on, you have all of the capabilities to have that best authoring experience. So let's go ahead and actually start from scratch, since this is a getting started Bicep. Where do you get started, right? So this is a main.bicep file, an empty file. And how do I declare my first resource in here? So the first thing that I do is I type resource, indicating that I want to declare any resource. And I follow that by a symbolic name. I'll get to that, what that means in just a second. But if I type here any beginning of any resource type, you can easily see that I already get some suggestions here on what to create. So I select storage account, which is one of the more easier examples to start with. I select an API version, I do an equal sign, and I do a couple of brackets. So as you can see, the engine already helped me get to the storage account declaration here, which is a combination of the resource type as well as the API version. Of course, we need to specify a couple of parameters, right? So you can easily also hover over this symbolic name and actually see all of the properties that are missing at this point. So we could do is go in here and start adding these properties. I would give it a name. Let's try to see if I can find a unique name for the storage account. We of course need to provide it with a storage account kind. Let's do blob storage. Another property we need is the location where we're deploying this. Let's do West Europe, since that's the region that I'm at. And we need a couple of more properties. Oops. One of those is the access tier, and we'll select a hot one. And the last one is the SKU, which is multiple properties, and we'll give it a name, which is standard LRS. And that's it. So as you can see, I got a lot of help, declaring this resource with all the drop-down list of all of the features and all the properties that were available. And it just helped me create this resource from scratch. So the next thing you probably want to do, and probably should show you, is that concept of the symbolic link that I have here as a, right? So the best way to show you that is, for example, let's say that I want to have an output for this template. I want to output something when it is complete. And it's going to be of type string, and it's going to be equal to SA dot. So as you can see, I now have dot property access towards the resource that I declared before, right? So now I have the properties of this storage account. So I could do something like, properties, primary endpoint, dot block, for example. As you can see, there's dot completion into all of the properties and sub-properties of there as well. And these symbolic names allow me to reference any previously declared resource within my template. So the next thing you'll probably do is make this template more reusable, right? In order to allow parameters instead of all of these ugly static values in here. So we do param. We're going to provide a parameter name. So let's do storage account name. And that is, of course, going to be a string. And that's also provided with a default value, which is the value that we have right here. Let's do another one. And since I'm very lazy, I'm just going to copy that in here. And let's do storage account location. It's, of course, also going to be a string. And let's give it a default value of, in this case, West Europe. And now what I'm able to do is I'm able to use these parameter names inside my template in order to make my template more reusable, right? So if I would now deploy this, I would have the option to either select the default name and the default location or specify something else, right? Another region, another name, etc. So that's a lot of help that we get in creating this template. And let's now take a look at what that would look like in JSON. So if I would transpile it, that's a process we talked about before, right? I could do something like bicep build and then the name of the bicep file. that's what you do, and that is what you had to use to do prior to being able to also deploy Bicep files directly to Azure. It's going to take a couple of seconds, but on the left-hand side, what you should see up here is the JSON equivalent of this Bicep file. There we go. Let's actually open it up side by side to do a quick comparison. So as you can already see, we went from 16 lines of code to 42, right? So, and if that all now did not yet convince you, you can clearly see the difference in left-hand side, right-hand side, in terms of complexity, overhead, with all of the brackets and the commas and the semicolons and the new lines, etc., going on. So left-hand side is way easier to understand, to read, especially if you're starting all the way from scratch. So that's the JSON template that we get. And I actually want to show you another way of creating resources. So although the creation of this resource went pretty fast, right? I was really supporting the code completion was supporting me in creation. But there's even a faster way. If I would do another resource here, let's quickly call it SA2, another storage account, another API version. And instead of doing the brackets here, I'm going to say required properties. And this fills in all of the required properties for me. So I could send in a name here, a location, and I could just tap in here and select all of the properties that I wanted. But that's even faster, right? So that helps you scaffold out. The process is called scaffolding in order to get all of the required properties, so the bare minimum to create this storage account. So if you thought that was fast, there's even a faster way. Instead of typing resource, I could type res dash. What this brings up is something that we call code snippets. So these are not required properties. These are actually code snippets, full snippets of code that community members or product team members have been adding in order to reuse. So I could just select, I don't know, a random thing here. Let's do, but I don't know, a Cosmos Gremlin database. There it is, right? So this is not only the default values, this is all of the values that the author of this code sample added in. This can also be multiple resources at the same time, which allow you to instantly get started with that template. So as you can see, go ahead.
Sorry, that is, I've learned two new things there straight away, right? So I thought you were quick just tabbing out all the options. But the Scadlin options there, I didn't even know there was like inbuilt templates that you could pull down from the community, right?
Yep.
The required elements there. I just think that's like AKS cluster, right? That's hot on my agenda at the moment. I mean, I think I'll be using that quite a lot.
Yeah.
Boom.
Yeah, there it is. Yeah. And in fact, it also contains a resource that I created back then, which is a Windows Virtual Desktop host pool. Still called WVD. I still have to send in the pull request to have that changed. But this was one of those things that I added into the repository as well. So awesome. They're definitely open to community members adding in code snippets as well. Okay.
Yeah. Awesome.
So the next thing I want to show you is we talked about the transpiling process, so getting from a Bicep template into a JSON template. But what about the other way around, right? What if you have a large background in JSON templates? Or what if you are downloading JSON templates from a repository or from the Azure portal, etc.? There is a way to decompile. Let's take a look at this. So I probably have to remove it so you can know I'm not cheating. So I have here an old school template.json. What I would be able to do is Bicep, not build, but decompile. I then provide the JSON file as a input. And as you'll see on the left-hand side, we will now be presented in a couple of seconds with the Bicep equivalent of the JSON file. So here it is, right? So here's that same storage account, but now decompiled from an existing JSON file. Now, of course, this is just a single resource, but it could have been, a really huge template with all kinds of resources, or you might want to use this in order to do some reverse engineering to see what the Bicep language is like. Super easy way to do that. Do note that, and we talked about that a couple of minutes ago as well, this decompiling process is a best ever process, right? So although any Bicep file that you will get as part of this decompile process is always a valid Bicep file that you can deploy, always make sure to double check, if everything is the way you want it to be. For example, what it does here is it generates fairly long symbolic names, right? You might want to shorten that into SA, for example. So always make sure to take a look at what has been created in order to make sure that it is actually what you thought it was going to do. But still, it allows you to do that decompile process in a pretty fast and easy way. The other way, and that is actually what I even like even more, is not transpiling from an existing JSON file, but actually grabbing a resource in Azure and taking a look at what the Bicep code would be. So let me open up the Azure portal. And this is just a random object, a random resource that I selected. You can do this with any resource that you like. If you open up the JSON view here, of course, you get the JSON code here, so you would be able to copy this in, put it into a JSON file and decompile it. But what I could also do is copy in this resource ID here, go back and right-click this file and I say I want to insert a resource. I paste the resource ID here, hit enter, and within a couple of seconds, hopefully, there we go. We now have the Bicep equivalent of the generated resource. So this have been using this a lot to actually do some reverse engineering to see how is an object being created, and what are the properties and what are the values that were used as part of that resource. So it's a super easy way to do some reverse engineering as well, using the insert resource option. Another great way to help you at least provide and produce code that is compliant to your own rules or compliant to common practices is something that's called linter rules. And linter rules allow you to define what are my rules, or within my company or within my department, that we think any template should be like. So let's actually run into one of those rules. So if I create a parameter here, let's do a secure password. Let's actually make it a secure string. As you can see, this is called a parameter decorator, making sure that this string is now secure, which essentially means that it doesn't end up in any log file or deployment history, etc. What I'm now going to do is actually pass it a default value. So let's do a not so secure password, 1, 2, 3. And a couple of things that you see notice here. So we have these nice yellow squigglies here. One is underneath of the secure password, which is because the parameter secure password is declared but never used, right? So that makes sense, right? I just declared it. I should either remove it or actually start using it within my template. But there's another one here saying secure parameters should not have hard-coded default values, which of course is very true. Because otherwise there's no reason into making it secure if we have plain passwords inside our code. So where are these rules coming from? If I scroll all the way down here, we have a file that's called bicep config, and bicep config now contains a couple of these linter rules. So no parameters, no unused parameters, no unused variables, outputs that do not contain secrets, etc. And the one we're running into is now the secure parameter default. So as you can see, it's called a warning now, which means that I would in fact be able to transpile this and deploy this, but it will only result into a warning. If I say, within my department or within our company, we want to make sure that this is always an error. If I save it and go back, it now has a red squiggly, which is not so much different, but it does now not allow me anymore to compile this file or deploy it somewhere because it contains an error that's as part of our linter rules. So this really helps you to make sure that your code is at least compliant to some of the basic rules, but also maybe some of the rules that you have internally. The last thing that I want to show you in regards to the VS Code extensions, at least, is parameter files. So right now I have this bicep file here with 2 parameters. Of course, I could have created them for all of the values and all the properties here. But for for this demo, I just had these two values. But let's say that I removed these values for now, which would mean that anyone who would deploy this template would have to specify the storage account name and the storage account location. So you could either do that, by passing them into the command line or into a template specification in Azure or in DevOps or whatever you're doing. But you can also use a parameter file, which is similar to the way that ARM templates also do that. And at least I have this struggle in the past as well, that at some point you want to create this parameter file, you need to copy in all of the values and start creating and crafting that template file. You can now directly create a template parameter file by simply right-clicking here and say, generate parameter file. So here is that file. Now, of course, right now it's very short, but you can imagine if I have, dozens of parameters, this is a super easy way to create a parameters file, which you can then provide and start adding in values as needed. And besides that, you might have noticed that a lot of actions are also now right-clickable. So building the ARM template that I did from the command line is now an option here. Generating parameter files, inserting resources, but also deploying. And we'll see that in a second as well. We can easily deploy a Bicep file directly from the context menu here into Azure. So that was just, I wouldn't say quick, but at least a summary of all the stuff that you get inside VS Code that help you, get started and create your own first resources. So, any questions up until now before we move on?
There was, there is a discussion going on in the chat. I'll get to that in a second. But did I see correctly that a parameter file is still a JSON file?
Yeah. That's correct. Yeah, so that's what they started out with to at least have some backwards compatibility between ARM and JSON. They are putting this, or they are having this on the roadmap to also make that into another format, which is probably more closer to the Bicep language than JSON. But yes, for now it's the exact same parameter file that ARM templates also use. Great question, though.
All right, there was a thanks for that. It makes sense, right? So eventually, we're still working with ARM, but it's abstracted away. So all right, Terraform destroy. So somebody is familiar with Terraform and asking if there is a equivalent of Terraform destroy in Bicep. Well, somebody else already, Bessard already responded like, hey, there's no destroy because there's not a state, right? With Terraform, you have a state.
Yep.
So there's no need to clean up your state by using a destroy. So you can just go and delete your resource group or deploy an empty template, as somebody else already said. So what's your take on this?
Yeah, that's a great question, and I think it's in line with a lot of questions that we get when I present topics around Bicep. Is how does it in more general, how does it compare to Terraform? And if I'm using Terraform today, should I be switching to Bicep, or what are some of the pros and cons of both languages? And I think that from my opinion, there's no reason if you're happy with Terraform to switch to Bicep. I just want to make that clear. Bicep is not there to replace everything else. Right. So definitely pros and cons for both solutions. So Terraform, for example, as many probably know, is multi-cloud, right? So Bicep is only for the Azure cloud, and Terraform allows you to deploy to other clouds as well, which is of course a big benefit. And Terraform uses a state file, so that is definitely correct. So it also becomes a very critical file. So it can be an advantage, but also sometimes a disadvantage because, well, losing the file or corrupting the file can lead to very interesting scenarios. But one of the great things that Terraform is able to do is that destroy function to remove all of the resources from a specific deployment, which is something that Bicep is not able to do, as you mentioned. But they are working on something that's called deployment stacks. There are already a couple of previews available for that, which allow you to deploy not a Bicep file or a Bicep deployment, but rather a stack of different deployments, which then in result would also allow you to remove that entire stack, again, similar to how a destroy function in Terraform works. So yeah, definitely pros and cons for both solutions. And if you've invested a lot in terms of learning the language, and if you're happy with it, stick with it. There's no need to change, but Bicep is really there to help any existing ARM template developers with a more intuitive way of creating templates going forward. Probably a long answer, but hopefully the question was answered.
That makes a lot of sense, right? Last question from me, right? Usually when I deploy to Azure, then I try to keep all the resources with the same life cycle in a single resource group, right?
Mm-hmm.
So that also means that I use one or multiple ARM templates in one deployment that deploys to that resource group. So if I would remove that resource group, I'll actually have a quote-unquote Terraform destroy then, right?
Yeah, if it is in that single resource group, for sure. But there are probably a lot of production environments or production examples where you're deploying into multiple resource groups. So although you're grouping, as you said, based on lifetime, there will always be resources that are residing in under other resource groups as well. So it does come close for some scenarios, but I think that it's not fully comparable with Terraform Destroy, which is one of the reasons, of course, that the deployment stack option is going to be added to the language as well.
Yeah, makes sense. All right. Yeah, lots more, but let's move on and let's answer a couple more questions at the end. Right?
Okay.
It's like opening Pandora's box, right?
It is, yeah. All right. Yeah, so let's step up our game and take a look at a bigger Bicep template that actually deploys, like you said, multiple resources, in this case, still into a single resource group. But here we have an example that deploys a virtual machine, right? So I have a resource for the VNet, I have one for the network adapter, and I have one for the virtual machine. If I were to right-click and build that ARM template and show you the comparison here, it's one thing I want to point out. So yes, again, the complexity, but we went over that. But let's take a look at let's do the network interface. So this is the ARM template code of the network interface. And as you can see, there is a depends on section here. So this is us telling the ARM engine, make sure that prior to deploying this network interface, the virtual network needs to exist, right? So they are dependent on each other. We need to explicitly tell that to the ARM engine. If we take a look at how that has been done in Bicep, or rather how that's not being done in Bicep, there is no depends on section here. So how did the compile process or a transpile process know about that depends on section and actually add it for you? It's because we're using those symbolic names. So this is the declaration of a network adapter. And as you can see, at some point, I need to specify my subnet. And what I do is I concatenate a couple of strings, but I'm using here the VNet, which is a symbolic name towards another resource, grabbing the ID. And based on that property that I get here, the depends on section is automatically added for us to help you, get the correct dependencies on resources that rely on each other. So definitely a great save. For now, it seems pretty obvious, right? Network interface and VNet, but you can imagine if you have, multiple depends-ons in different resources and different resource groups, it can become very complex. Bicep is handling that for you automatically. So that's something that I wanted to point out. And actually now take a look at the scenario that Robin just described as well, is deploying into multiple resource groups. I have an example here, example number 9. So the first thing that I did here is actually change the target scope. So that's needed because by default, if you deploy anything into Azure, the default scope is always that resource group, right? So these are the options, and by default, all resources will remain into one resource group. And as I mentioned before, you rather want to have these groups by lifetime or by purpose, or maybe for production or a test, a separate resource group. The way you do that is changing the target scope into subscription in one level higher, which allows you to deploy resources into multiple resource groups at the same time. So let's dive in to that, and let's take a look at this resource, which is actually a resource group itself, right? So we're creating a resource group here. And we're also using a conditional deployment. So this allows us to only deploy it in certain conditions. And in this case, it's a Boolean value, right? So if you pass a true towards this parameter, it will be deployed. And if false, it will not be deployed. Simple example, but you can imagine more advanced scenarios where you're deploying something based on a specific condition. So getting into, deploying into multiple resource groups, how does that work? It's in combination with the concept of modules in Bicep, which is a very strong feature, I think, in Bicep language as well. So instead of using the resource keyword, we're now using the module keyword followed by a same symbolic name and then followed by another file. So instead of having a resource group and an API version here, I'm now pointing to another file. And I'm basically saying deploy everything that's inside this Bicep file and pass that Bicep file these parameters, which I collected somewhere above. And so here is that scope that I mentioned before. So this allows me to say anything that's deployed or anything that's declared in this file will be deployed in this resource group. So I could have things into multiple resource groups at the same time. So this Bicep file, if you take a look at it, so it's called 9, in this case, VNet module Bicep. This is just another Bicep file. There's absolutely nothing different between a module and a Bicep file. They have the same layout with parameters, variables, resources. And in fact, I could just deploy this separately to the Azure cloud. But in this case, I'm using it as a module to be able to reuse it for other projects or other deployments, etc. So that's the concept of modules, allowing you to extract pieces of code, put them into separate module, and share them with your colleagues or community or anywhere else. And we should probably also address loops in that matter as well. So let me open up the VM module here. So again, this is just another Bicep file, but what we do differently here is we do a couple of things. One is that we're deploying this resource. So in this case, it's a virtual network adapter. We're not deploying it once, but we're deploying it multiple times. So this is that for loop rule where I said for I, and I is an index, in range 1 to number of virtual machines, deploy this resource. So this allows me to deploy, in this case, 5 network adapters all at the same time, so all in parallel. So the ARM engine is clever enough to know that they're not dependent on each other, and he will deploy 5 network adapters at the same time. And similarly, I'm doing the same thing for the virtual machine, of course, which will result into 5 virtual machines, in this case, all with a unique name, because I'm reusing that index, that number here, concatenating into the name of the virtual machine. So the virtual machine will be something like VM name -1, -2, -3, etc. The other great thing that it's not very known, I think, is the existing keyword. So as you can see, throughout this template, what I'm using a lot is these symbolic names, right? So in the creation of the network adapter, I'm pointing to the VNet, which is symbolic name to the VNet, and then grabbing the ID. But what if I want to grab a property from a resource that I didn't declare in this template, in this Bicep file? Then I can use the existing keyword. So this allows me to point to, in this case, an existing VNet. So I don't create the resource here, but I'm just pointing to it in order to retrieve that the symbolic name here and reuse it, as you can see, throughout the template to get that going. So that's the existing keyword, which allows you to point to resources within the same resource group, but even outside of that, or maybe even inside of another subscription in that case. So some of the more advanced stuff, and I'm sure this went pretty fast, but just to show you a couple of things that you can do, with the loops and with the existing keywords and with the modules, which are very popular as you start to grow, your Bicep files and want to extract pieces to make it more manageable. So speaking about management, the more modules that you add and the more code that you add, at some point you probably want to have some kind of visualization about what you're actually about to create. And you can do that inside VS Code. Again, it's the magic right click here. If I do the Open Bicep Visualizer, this will now give me a visualization of what my template is about to deploy. So as you can see, it nicely put them into separate containers, which are pointing to the different modules that I have and all of the resources that I'm about to create. This is also an interactive diagram, so I could just point this into the diagram that I want to, or export it for documentation, or share it with users, with other administrators, in order to show what we're actually creating as part of this template. What I also like about this approach is that, for example, if I would do a side-by-side comparison, a side-by-side opening here, So let me just zoom this in a little bit. So right-hand side is the visualization, left-hand side is the template. If I would make, for example, an error somewhere in, I don't know, this declaration, it instantly gets updated, and I can zoom in and I see in which model the error actually occurred. So this is interactive while we are creating, updating, and making mistakes in this case as well. So for example, if I would create another resource group here, we just call it, give it a unique name, it instantly gets added here on the right-hand side while I'm typing this. So it's not only useful for documentation or for taking a look at what a template does, but it also gives you a continuously updating diagram of what you're about to create as you are typing your template. Pretty cool thing, I thought.
I haven't met an engineer that loves to do documentation, right? So it's an absolute great tool to visualize your infrastructure that you're going to deploy. It's like another form of validation as well, like you were just saying there. If I had errors or what is it I'm deploying, you can then before this goes through like a change release cycle, you can then use the export to say this is exactly what I'm deploying. It's very effective. It's one of the when I show this tool to customers, you always see the eyes light up in the room, right? It's a good feature.
Yeah, I love how it actually creates while you are typing. I'm sure that at some point it will become very annoying if you're right in the middle of your code and you constantly see change on the left, on the right hand side. But yeah, definitely useful for those scenarios where you actually want to, like you said, documentation or export it. And that, by the way, is the only function that I'm missing currently. There's no way to export this to a PNG or to a PDF, etc. I know this is on the roadmap, but hopefully will be added soon. But for now, yeah, just run it full screen and take a screenshot or whatever. But it's a great feature for sure.
Yeah, the feature is really, really awesome, and especially when you work with multiple resource groups, then it's really good to see like, okay, these resources are going there and these resources and ending up there, right? So yeah, I love all the things that I've just saw. So yeah, way to go.
Good to hear. So looking at the time, so I don't want to spend the entire evening talking about this, but there's one thing I want to show you because I think we mentioned it in the beginning, talking about some more advanced production, things from the field. I have an example here, which is 6 main.bicep. Let me just close this file for now. There we go. 6 main.bicep, and this is a huge bicep file, right? So relatively huge. This is about 300 lines of code, but it actually leverages all of the stuff that we just talked about, right? So doing the target scope and doing the parameter decorators here to create secure strings, a lot of grabbing of parameters to make it as reusable as possible. Now, of course, this is overdoing it, but this is just for example, for demo purposes, of course. That's the reason that all of these things also have default values in that case. But as you can see, we are leveraging the concept of modules as well. So the first thing we do is actually create a whole bunch of resources with the same prefix and postfix with the name in between. And yes, I could have done this in modules as well, in case you're wondering. But here you can see that, things leveraging like the array that we talked about. This is a more advanced one that we have here. And then we have all kinds of modules. So I have a separate module in this case for, the other stuff that I like to do, Azure Virtual Desktop deployment. So this deploys an entire AVD control plane. This module deploys a subnet and a VNet that I need. This module deploys an Azure Log Analytics workspace and adds all of the properties in there. A shared image gallery, a file services storage account with all kinds of shares in there, etc., etc. So this is the main file that leverages all of the modules that I created, and I could take these modules and go to another customer or another subscription or another purpose and reuse those modules and do the same thing all over again by simply changing the parameter files that I needed in order to deploy this. So I have a question actually for you. Let's go ahead and compile this or transpile this into a JSON. And how many lines of code do you think will generate with this Bicep file, considering it's 356 lines? Any ideas?
I'm gonna go for like 5,000 lines, roughly.
Okay.
I'm probably exaggerating here, but you know, from what I've seen, you've got all these sub modules, right? That it's going to be pulling through. That's what I'm trying to get at. It's not just what you've seen in the manifest file. Yeah, 5,000, right?
Yeah,
that's what I'm thinking.
Yeah, 10,000.
10K, right?
10K would be funny, but what you mentioned is exactly the reason why I'm showing you this. Because if I build this ARM template, that's sometimes being mistaken. I do not.
I can hear the fans kicking in now. Right.
The winter rule that's kicking in. Hold on. I should probably change this back to a warning first. There we go. Let's
I'll
see.
go for 3,500, by the way. For
that's conservative.
You're getting close. So this is, it's 2,000 lines, which is not so bad.
Okay.
Not so bad. But of course, the reason is that, like you said, it's not just the main Bicep file, but it's getting all of the modules and all of the declarations in there as well, in order to do that. So, just to point out, if you wanted to do this in JSON, you would have to, worry about stuff like nested deployments and incremental deployments and all of that mess that we used to do in ARM templates, which is now literally extracted for you as part of the modular approach. So, that's what I want to show you, at least to what the end result would be. And the next question would then be, let's take a look at the visualizer to see. I'm not sure if that actually works, but we'll see. Open visualizer. There we go. So this is our deployment right now. And of course, you cannot read it, but you can zoom into it and take a look at all of the objects and all of the resources and modules and how they're all connected to each other. So at these occasions, definitely the visualizer is of help to find out what the hell I'm doing inside all of these templates.
No, but even as a reference for your documentation, I always struggle. Like, okay, how am I going to be creating a readable, understandable diagram that doesn't include too much information, et cetera, right? And then take a look at this, and you're like, oh, wait a minute, I'll just put these pieces there, and then it's just as an inspiration as well, I guess.
Yeah, for sure. Like the format of it as well. This would be consistent. So in 5 years' time, everybody will be more familiar, right, of reading these kind of diagrams that have been outputted through the visualizer tool. So it's like a consistent format as well, because everyone has their own spin, right, when they're in Visio and they're building the diagrams out. But with this, it's more, you've got the icons, the structure, and everything. I mean, it's very powerful.
Yeah, in fact, I've also seen a couple of docs pages where they're actually using the same concept to explain something. And that's what I would like to see as well, is have some more consistency between, stuff that's explained in the docs pages, also showing these same diagrams to get everyone aware of, like you said, how they're made up and what the icons are and how they're constructed. So the next thing we're probably waiting for is actually being able to draw a new object here and have the Bicep code be generated for us. We'll see if that ever happens. But for now, it's a great way to visualize stuff.
Yeah, wow. I'm still digesting everything that I just saw, right? But
I can imagine, and that's even more stuff to talk about. But I think that this hopefully provides everyone with a good starting point, like we said, to get started with Bicep, and to get started from scratch and see how at least the VS Code helps you along the way with all of the extensions in there as well. So hope you enjoyed the demo.
Definitely did.
Completely. Yeah, it was awesome. I learned new stuff, right? So I'm just like, stuff that will make my life easier as well, and then in turn help folks out in the community or our customers out better as well. So it's a really good demo, very informative. Robin, again, your take on it.
Mind's blown, right? Especially the integration with Visual Studio Code. Right? And we had that session with Brendan, and he was talking about all the stuff that's being developed around AKS and Kubernetes from Visual Studio Code as well, right? And now you see the capabilities with the Bicep language. And I'm always going back and forth between IntelliJ and my Visual Studio Code, right? Because I like the Golang support and everything that's in IntelliJ. Mm-hmm. But whenever I see stuff like this, I'm like, yeah, well, at one point I just have to switch back to Visual Studio Code.
Right?
Yeah. So no, it's mind's blown. Of course, I read the book, but seeing this in action and having, the author explain it while going through everything is extremely powerful. So yeah, I'm stoked, man. I'm stoked about this session. I really am. Of course, I'm a little bit biased, but I think it's an awesome session. Really,
that's good to hear. Yeah. So the last thing I should probably share then is a little bit more information if you want to get started with all of this. A couple of useful links that you might find interesting. So of course, all of the docs documentation that is out there, aka.ms/bicep is the way to get started. It contains a lot of information about the stuff that we just talked about, with a lot of sample codes as well. And also I can really encourage you to attend is the Bicep monthly community call. I think you are probably both in there as well. But if not, it's fully open as long as you sign up for it using this link here. And it allows you to have to join the Bicep community call, which is led by the product group members, product team members every month. And they're explaining what they're doing, gathering feedback. It's a really, really interesting, really open session for feedback as well. So definitely can encourage you to join that as well. And of course, the GitHub location, that is where you'll find all of the latest Bicep versions and even nightly builds. So being able to take a look at what is coming even before it is public, as well as all of the source code, and provide, like I said, feedback or pull requests or a change that you would like to see. And the last thing, I should probably show you that as well, live might help, is the learning path. So this is available to get started as well. Of course, we've seen a lot during this session, but this contains a couple of modules that help you along the way with the fundamentals, with the more intermediate stuff, as some of the advanced stuff that we also touched on today. So if you open up one of these modules here and you dive in, you can actually see, there's a lot of stuff that we did today, right? So what is Bicep? How does it work? When to use it, etc. But also has a lot of interactive sandbox demos that you can try out to try stuff and test your knowledge and maybe even gather some XP points. But besides that, it's a really great way to start learning it as well. So if you thought this was a lot of information and you're still not sure where to start, I would really suggest to get started with this.
Oh yeah. Don't forget.
Yeah, another great place to start as well, right, is this book.
Yeah.
It's called Getting Started with Bicep, Infrastructure as Code on Azure by Freek Berson. Well, that's a coincidence, right? So
yeah, it is.
Yeah, awesome, right? I'll make sure that I revisit this slide and I'll put the links in the description of the video. Okay. And let's see, I think I broke our subscribe now button, Kev. Let's see if it's working. Yeah, it's not showing up somehow.
Yeah. I can quickly run through the marketing spiel, right? It's not
yeah,
an issue.
well,
but again, thanks to our amazing guest. Thanks for coming on. Thanks for demonstrating. Thanks for teaching. Some amazing features and education around Bicep there. So if you like what we do, don't forget to like and subscribe and click the bell icon. Also, it just seems to be going off the charts at the moment, but the community that we've launched, right? So if you go to community.streamingclouds.io, you can join our Discord server there, right? Where there's folks in there from across the industry, some really familiar faces, some rock stars in there that will be able to help you. Especially, we've even got a channel around infrastructure as a code as well, right? So if you've got any Bicep questions or any other questions around Azure infrastructure as a code, just come in and join the community.
Oh, and Freek's in there as well, so you can ask questions directly.
There you go.
So yeah, the join.
Yeah,
Sorry, Freek, go ahead.
No, I was wanting to say I just recently joined that community, so it's a great opportunity to get everyone together, and happy to answer any additional questions using that channel or Twitter or LinkedIn. That is all fine.
Awesome. Yeah, my like button is broken, Kevin. So and I forgot the names and everything. So I made a mess of the production today. So I'm sorry. Luckily, somebody saved our session with awesome demos and awesome information. So once more, Freek, thank you. Kev, thank you. I never thank you, right? So let me use this opportunity, right? Thanks, man.
Thanks, Freek, for coming on. Appreciate it.
Sure.
All right.
Okay.
See you all next time.
All right. Bye.